Let's understand what is center of mass and what is center of gravity. These terms, center of mass and center of gravity, they are kind of interchangeably used. So is there any difference between center of mass or center of gravity? Let's start with center of gravity first. So what is center of gravity? Center of gravity is that point where the whole body can be balanced. About this point, that is, there is no translation, there is no rotation. The body is not rotating about this point, neither along the x-axis nor along the y-axis, and it is also not, there is no translation also. We can say center of gravity is that point where the whole body can be balanced. That is, the translation equal to 0, that is net acceleration is equal to 0, and net torque is also equal to 0, that is, there is no rotation about that axis also. So let's start with some very basic examples, and from there we understand the concept of center of gravity and how it is calculated. Let's say we have two particles or 2-point mass system, 1 kg each. They are separated by a distance of 10 meters. When we say center of gravity is that point where the whole system can be balanced, so we join them by an imaginary massless rod, and we know that is, if this is 10 meters, suppose the distance between the two is 10 meters. So if we have to balance it, the distance between the two is 10 meters. So we know if we have to balance it, it should be 5 meters from here or 5 meters from here. But how do we find it? By the basic definition of center of gravity. So as we know, center of gravity is that point about which there is no translation, there is no rotation. Let's say we support it over here. We are deliberately not taking as 5 meters because 5 meters, through common sense, we know the answer should come as 5 meters. But we are following the general rules of physics, and from there we'll get the answer. What is this, the distance from here, or what is the distance from here, and we'll see whether this answer matches the common sense answer or not. That's why we have taken the value of these masses, so that we already know the answer, what should be the answer. So over here, suppose this is x. So this distance from here to here comes out with 10 minus x. And we are supporting over here. As I had balanced the notebook on my fingertip, similarly, we are balancing this also, these two masses which are connected by an imaginary massless rod, and we are balancing it over here. So about this, there is no translation, there is no rotation. So obviously, that is, this is applying a force this way, and the earth is applying onto this force, that is 10 Newton. M into G, G we are taking it as 10 meter per second square. So the earth's pull is 1 into 10, that is 10 Newton. Only for the ease of calculations, we are taking G as 10 meter per second square. Similarly, 10 Newton force is being applied this way. If we take this point as C, that is center of gravity, so we say that is about this, that is center of gravity, where we can balance the whole body, about which there is no translation, no rotation. So it means if the whole thing is balanced over here, that is net force along y-axis should be equal to 0. It means the upward forces, that is F, should be equal to downward forces, 10 plus 10. So this F, that should be equal to 20 Newton, 1. Second is about this point, when the whole thing is balanced over here, it means there should not be rotation about this point. So it means that clockwise torque, they should be equal to anti-clockwise torque. So when we look over here, that is, if C is axial rotation, about this we see the torque of this force and this force. This force is trying to rotate it in the anti-clockwise direction, whereas this force is trying to rotate it about this axis in the clockwise direction. And this body is not rotating about C, neither in the clockwise direction nor in the anti-clockwise direction. There is no alpha, it means the net torque is equal to 0. If the net torque is equal to 0, clockwise movements is equal to anti-clockwise movements. And now we know that is torque of this force about this axis, that is torque about C, net torque about C should be equal to 0. It means this torque, that is 10 into x, force into perpendicular distance between line of force and acceleration, that is this torque should be equal to the torque clockwise because of this force about this, that is 10 force into perpendicular distance between line of force and acceleration, that is 10 into 10 minus x. It means 10x is equal to 100 minus 10x. This goes over here. 20x is equal to 100. So x comes out to be 5 meter. So obviously this is the same answer what we had expected through our common sense understanding of the things.